And based on what you were describing, this could soon be the biggest story in the world. Literally the biggest story in the universe.
I need to tell you about something that's been on my mind since December 19th passed. The world watched, the comet came, and then, oh, nothing. No signal, no spectacle, just a silent passage 270 million kilometers from Earth. The media moved on within hours. The headlines faded by the next morning. Most people exhaled, shrugged, and went back to their lives, satisfied that the interstellar visitor had done exactly what the astronomers predicted, passed by without incident and continued on its way. But here's the thing. The scientists didn't move on. They're not packing up their telescopes. They're not filing away their data and calling it a day. They're leaning in harder than ever. And what they're proposing now, what they're seriously discussing in peer-reviewed papers and academic conferences, it's not what I expected at all. They're not asking, what is it, anymore. That question hasn't been answered, not definitively, but they've moved past it. Now they're asking something else entirely. They're asking, what can we do with it? And honestly, that shift in thinking might be the most important development in this entire story. It changes everything about how we relate to objects like 3I Atlas. It transforms them from mysteries to be solved into opportunities to be seized. Before we continue, if you're finding this interesting, you can subscribe anytime and turn on notifications. We're going to be covering the March-Jupiter encounter extensively over the coming months, and trust me, you won't want to miss those updates. There's a lot more coming. Let me walk you through what's happened in the last 48 hours, because there's new data that just dropped, a new size estimate that changes the physics completely, new radio scan results, and a proposal from Harvard's Professor Avi Loeb that sounds like pure science fiction but might actually represent humanity's best realistic chance to reach the stars within any reasonable time frame. December 19th, 2025 was supposed to be the climax of this story. 3I Atlas made its closest approach to Earth that day, 70 million kilometers. Safe, distant, completely invisible to the naked eye. You couldn't see it even if you knew exactly where to look without serious telescope equipment. The skeptics called it a victory lap for conventional science. Just a rock, they said, an interstellar snowball that wandered into our solar system by chance, swung around the sun, and kept on going. It didn't stop, it didn't signal, it didn't do anything dramatic or unexplainable. It just kept going, exactly as the orbital mechanics predicted it would. And they're right about that last part. It did just keep going, but that just keeping going. That's exactly what has some of the most serious scientists on Earth genuinely excited right now. Not worried, not disappointed that nothing dramatic happened during the flyby. Excited. Because they're seeing something in that departure that the rest of us might have missed. Professor Avi Loeb has been tracking 3I Atlas since it was first discovered back in July. He's the Harvard astronomer who first suggested that Oumuamua, the first confirmed interstellar object we ever detected back in 2017, might be artificial in origin. That hypothesis was controversial, to put it mildly. Many of his colleagues pushed back hard, but his methodology has always been rigorous. His math has always been sound, and his willingness to ask uncomfortable questions has opened up conversations that needed to happen. His latest analysis of 3I Atlas isn't focused on what the object is. He's moved past that debate, at least for now. Instead, he's focused on what we could potentially use it for. And his proposal is genuinely radical. Here's Loeb's argument, and I have to admit, there's an elegance to it that's hard to dismiss. Think about the Voyager probes for a moment, Voyager 1 and Voyager 2. We launched them almost 50 years ago now. They're the fastest objects humanity has ever built. They've crossed the heliopause and entered interstellar space. They're our furthest ambassadors, carrying golden records with sounds and images from Earth, messages in a bottle thrown into the cosmic ocean. And yet, despite being the fastest things we've ever created, they've barely scratched the surface of interstellar distances. At their current speed, it will take them approximately 30,000 years to reach the distance of the nearest stars. Let that sink in for a moment. 30,000 years. Human civilization as we know it, from the first agricultural settlements to right now, spans maybe 10,000 years. We're talking about 3 times the entire length of recorded human history. Civilization might not even exist in any recognizable form by then. We have absolutely no idea what humanity will look like in 30,000 years, or if we'll even still be here at all. That's the tyranny of distance we're facing. That's the prison wall we're up against when we talk about interstellar travel. But 3i Atlas is different. It's moving at 60 kilometers per second. 60. It's exiting our solar system faster than anything we've ever launched. Faster than Voyager. Faster than New Horizons. Faster than any spacecraft we could conceivably build with our current chemical rocket technology. And Loeb's question cuts right to the heart of our assumptions about space exploration. Why build a slow ship when a fast one is already passing by? He's proposing that we fundamentally change how we think about interstellar objects like 3i Atlas. Not as curiosities to be studied from a distance. Not as potential threats to be monitored and worried about, but as infrastructure, transit systems, cosmic freight trains passing through our station on routes we didn't build and don't control, but might be able to use. If we could intercept this object, or the next one like it that passes through our solar system, we could potentially attach a payload, a scientific probe, a time capsule filled with human knowledge and culture, a message in a bottle for whoever or whatever might find it millions of years from now. If we could hitch a ride on an object like 3i Atlas, Loeb calculates that we could reach the depths of interstellar space by approximately the year 10,000 AD. Now, that's still an incredibly long time by human standards. But it's 3 times faster than Voyager's trajectory. It cuts the travel time by roughly 20,000 years. That's not nothing. That's a fundamental improvement in our ability to project ourselves beyond this solar system. And here's where it gets personal. Loeb said something in his recent paper that genuinely stopped me in my tracks when I read it. He said he would be willing to donate his own biological remains to such a mission, to have his DNA, his genetic code, carried out into the galaxy on the back of an interstellar visitor. It's a poetic idea when you think about it. Becoming an interstellar traveler after death. Having some essential part of yourself, the blueprint that made you who you were, sailing between the stars for millions of years. Long after your name is forgotten, long after human civilization has transformed into something unrecognizable or vanished entirely, some fragment of your existence would still be out there, crossing the void between stars. But poetry aside, it raises a very practical and very difficult technical question. How do you catch a train that's moving at 60 kilometers per second? We can't land on it with any technology we currently possess. The energy requirements to match that velocity are far beyond our current chemical rockets. We'd need something revolutionary, something we haven't invented yet. But Loeb suggests we might not necessarily need to land. We could potentially use a high-powered laser to engrave a message onto the object's surface as it flies by. Think about that for a moment. A tattoo on the hull of a visitor from another star. Our calling card etched into an object that will travel the galaxy for millions of years. Alternatively, we could design a specialized interceptor spacecraft. Something small, light, and incredibly fast that could crash into the object and stick. Like a barnacle attaching to a whale. The interceptor wouldn't need to match the object's full velocity, just get close enough to make contact and hold on. This changes the paradigm completely. We're not just looking at these objects as scientific puzzles anymore. We're looking at them as potential transportation infrastructure. Cosmic highways we didn't build but might be able to access. But before we start packing our bags for the stars, we need to understand what this particular train is actually made of. And the latest data on that front is genuinely confusing. A new paper has just been published in the last 48 hours regarding the size of 3i Atlas. For months now, ever since discovery, we've been debating how big it actually is. The comet, that enormous cloud of gas and dust surrounding the nucleus, makes direct measurement extremely difficult. We've seen estimates ranging from a few hundred meters to several kilometers. Different telescopes, different techniques, different assumptions about albedo and composition, all yielding different numbers. The new analysis takes a different approach. It combines data on the object's non-gravitational acceleration, That's the extra push it gets from venting gas acting like tiny rocket thrusters, with models of how much mass would need to be ejected to produce that acceleration. And the conclusion? A nucleus diameter of approximately 1 kilometer. 1 kilometer? That's remarkably small. Significantly smaller than the city-killer asteroids we usually worry about in planetary defense scenarios. About the length of 10 football fields laid end to end. In cosmic terms, it's tiny. A speck. But here's where the physics gets uncomfortable. A 1-kilometer rock shouldn't be behaving the way 3I Atlas is behaving. The paper notes that, to produce the amount of dust and gas we're observing, the massive tail, the extensive coma that stretches for thousands of kilometers, a 1-kilometer object would have to be shedding mass at an absolutely incredible rate. It would essentially be evaporating before our eyes, losing significant fractions of its total mass every time it gets close to the sun. And commenters on the paper are already pointing out the obvious implication. If a 1-kilometer nucleus is producing all that debris through natural sublimation, through ice turning to gas under solar heating, shouldn't it have broken up by now? Shouldn't the structural stress of all that violent outgassing have torn it apart? That's a valid question, and nobody has a completely satisfying answer. If it's a natural ball of ice venting that hard, the forces involved should be ripping it to pieces. But it's not falling apart. It survived perihelion intact. It's still in one piece. It's still accelerating. It's still on course for Jupiter. This implies one of two scenarios. Either 3I Atlas is made of something considerably more dense and structurally strong than typical cometary material, something that can withstand massive structural stress while simultaneously venting gas, like a geyser, or the venting we're observing isn't purely natural sublimation. There might be something about the physics we don't fully understand, some mechanism we haven't accounted for. We don't know which scenario is correct, but the numbers don't quite add up with our standard models for how comets should behave. That's not me saying it's artificial. That's me saying the science isn't settled yet, and anyone who tells you they have all the answers is overstating their confidence. Now, there was a genuine concern in the weeks before the flyby that 3I Atlas might be dusting us. That material from its coma, that vast cloud of gas and particles, might be falling into Earth's atmosphere as we pass through the object's general vicinity. We know from spectroscopic analysis that the coma contains hydrogen cyanide among other compounds. That's a poison. In sufficient quantities, it's deadly to most forms of life on Earth. Should we be worried? Loeb addressed this question directly in a recent update titled, "Will material from 3I Atlas arrive on Earth?" The short answer, thankfully, is almost certainly not. The solar wind is our protector here. That constant stream of charged particles flowing outward from the sun acts like a shield, pushing the gas and dust from the comet's coma away from the inner solar system. Loeb's calculations show that any particles smaller than a micrometer in diameter get swept away almost instantly by solar radiation pressure. They simply can't fight against that outward push to reach Earth. And any larger chunks, rocks bigger than a meter in diameter, are statistically too sparse and too randomly distributed to have any meaningful chance of hitting our planet. We're simply not going to be poisoned by the comet's tail. The geometry doesn't work, and the physics is on our side. That's genuinely reassuring. We've also been actively listening for signals. The Search for Extraterrestrial Intelligence, SETI, has been paying close attention to 3I Atlas since its discovery. The Allen Telescope Array in California spent over 7 hours on July 2nd pointing directly at the object's coordinates. They were looking for techno-signatures, artificial radio emissions, any kind of beacon or signal that might indicate this wasn't just a natural chunk of ice and rock. They found 74 million signals during that observation window. 74 million individual hits registered by their equipment. Now, before you get too excited, that's actually completely normal. The sky is absolutely full of radio noise. Satellites in Earth orbit, GPS systems, terrestrial communications, aircraft, ships, all of it creates a constant background hum of electromagnetic interference. The job of SETI astronomers is to filter all of that noise out and look for something that doesn't match known sources. They filtered the data meticulously. They removed interference from known satellites. They accounted for terrestrial sources. They applied every standard technique for separating signal from noise. When they were done, they were left with 211 hits. 211 signals that came from the direction of 3i Atlas and didn't match any known background source in their databases. They analyzed those 211 signals carefully. They studied the waveforms, looking for patterns that might indicate artificial origin. The conclusion, published in their report? No signals worthy of additional follow-up. They characterized all 211 as most likely being noise that slipped through their filters, not genuine transmissions from the object. But here's the genuinely interesting part. They established an upper limit on potential transmissions. Based on their equipment sensitivity and the distance to the object, they determined that if there is a transmitter on 3i Atlas, its power output would have to be somewhere between 10 and 110 watts. Think about what that means. 100 watts is a light bulb. If 3i Atlas is transmitting anything at all, it's whispering, not shouting. It's not broadcasting a powerful beacon meant to be heard across the solar system. If there's any signal at all, it would be a low-power, directed beam, easily missed if you're not in the right place at the right time with the right equipment pointed in exactly the right direction. Is that meaningful? Is that evidence of something? Honestly, probably not. Most natural objects don't transmit anything. The lack of a strong signal is exactly what we'd expect from a chunk of ice and rock. But it's worth noting that absence of evidence isn't the same as evidence of absence. We looked, we listened, we didn't find anything definitive. That doesn't prove there's nothing there. It just means we didn't detect anything with the instruments and observation time we had available. The universe doesn't always make things easy for us. And this brings us to what happens next, because the story of 3i Atlas is far from over. On March 16, 2026, the object will pass within 53 million kilometers of Jupiter. In astronomical terms, this is a gravity assist maneuver, a slingshot. The object is going to use Jupiter's enormous gravity well to accelerate even faster, stealing a tiny bit of the planet's orbital momentum to fling itself out of the solar system at even higher velocity. 53 million kilometers might sound like an enormous distance, and by human standards, it absolutely is. But in cosmic terms, it's remarkably close. Close enough for the object to feel Jupiter's massive magnetic field, the strongest of any planet in our solar system. Close enough to pass through the outer edges of Jupiter's intense radiation environment. And here's what makes this trajectory genuinely interesting from a scientific perspective. If 3i Atlas is truly just 1 kilometer across, if it's really that small and dense, then hitting that specific window at Jupiter with that level of precision requires remarkable navigational accuracy. Think about the path this object has taken through our solar system. It entered from above the ecliptic plane, the flat disk where all the planets orbit. It dove down toward the sun-survived perihelion at a distance that should have stressed any natural comet to its limits, missed Earth by a comfortable margin during its closest approach, and is now threading through the solar system toward a precise encounter with the largest planet. If this were just a random rock on a random trajectory, that sequence of close approaches would be quite a coincidence, quite a lucky shot. But we know 3i Atlas isn't just falling passively through the solar system. The non-gravitational acceleration data confirms that the object is speeding up more than gravity alone can explain. Something is pushing it. The official explanation, the one that appears in all the scientific papers, is outgassing. Ice turning to gas under solar heating, jetting off the surface and acting like tiny rocket thrusters. Newton's third law in action. And that's almost certainly what's happening, at least in part. But the question remains, a 1 kilometer object shouldn't have enough volatile ice to push itself that hard, that consistently, without falling apart under the structural stress. So what's actually happening? What are we missing? We have the Juno spacecraft at Jupiter right now, actively conducting science operations in orbit around the giant planet. NASA has already said that Juno isn't designed to track fast-moving interstellar objects. Its camera, called JunoCam, is primarily a public outreach instrument rather than a high-precision tracking telescope. They're managing expectations, making it clear that we shouldn't expect close-up images of 3i Atlas as it passes through the Jovian system. But I find myself wondering, When March 16th comes around, when an object that has captured the world's attention passes within 53 million kilometers of Jupiter, do we really believe that every instrument in that region of space won't be paying attention? Whatever Juno can see, whatever data it can gather, I suspect someone will be looking at it very carefully. After Jupiter, where does 3i Atlas go? The trajectory takes it outward, away from the Sun, away from the warmth and light of the inner solar system. Past the orbit of Saturn, past the orbit of Pluto and the other dwarf planets of the Kuiper Belt. Into the Oort cloud, that vast sphere of icy bodies that surrounds our solar system at distances measured in thousands of astronomical units. And then into true interstellar space, the void between stars where nothing exists except the occasional atom of hydrogen and the faint glow of distant galaxies. The new orbital calculations, refined with data from the flyby, suggest that 3i Atlas is heading in the general direction of the Hyades star cluster. Specifically, its trajectory points toward a star called Epsilon Tauri. Why is that interesting? Epsilon Tauri is an orange giant star located approximately 106 light-years from Earth. It's a star in the late stages of its life, having exhausted the hydrogen in its core and expanded to many times its original size. It has at least one confirmed planet, a gas giant considerably larger than Jupiter, and the Hyades cluster itself is about 6 to 5 million years old. That's relatively young for a star cluster, but old enough for many things to have happened, old enough for planets to have formed, for atmospheres to have developed, for chemistry to have become complex. I'm not saying 3i Atlas came from Epsilon Tauri. I'm not saying there's anyone there waiting for it to return, or that this trajectory is anything other than random chance. But when you plot the object's path through space and see where it's pointing, the mind wanders. You can't help but wonder whether this is a random direction determined by the chaos of gravitational interactions in whatever solar system birthed this object, or whether it's something more like a course, a heading, a destination. There's one more piece of data from the new papers that caught my attention and that I think is worth discussing. The diameter estimate paper mentions that the momentum changes observed in 3i Atlas could be partially explained by the ejection of fragments. Not just gas sublimating off the surface, but actual chunks of material breaking away from the main body. The authors model this as icy fragments separating from the nucleus under thermal stress, which is standard comet behavior that we've observed in many solar system comets before. But it raises an interesting question. Where did those fragments go? If pieces separated from 3i Atlas during its passage through the inner solar system, particularly during the intense heating of perihelion, they would have been given different velocity vectors than the main body. Some would have slowed down. Some might have entered different orbits. Some might still be drifting through the inner solar system right now, small, dark, cold, and essentially invisible to our current detection systems. Have we detected any such fragments? No, we haven't. Our surveys haven't picked up any objects that can be definitively linked to 3i Atlas. If they exist at all, they're probably just inert chunks of ice and rock following their own lonely trajectories through space, slowly sublimating away to nothing over thousands or millions of years. But the scientists will keep looking. That's what scientists do. They follow up on every possibility, even the ones that seem unlikely, because you never know what you might find. The Project Lyra discussions have picked up again in light of all this new data. Project Lyra was originally conceived as a mission concept to chase down Oumuamua after it passed through our solar system in 2017. The idea was to design a spacecraft fast enough to catch up with an interstellar object and study it up close, maybe even land on it, or return samples to Earth. But Oumuamua was long gone before we could get anything off the launch pad. The window closed before we even finished the preliminary mission designs. 3i Atlas offered another chance. A second interstellar visitor, this time detected earlier in its approach, giving us more time to prepare. But the window is closing again. To catch 3i Atlas now, we would need to launch essentially immediately. We would need a rocket ready on the pad, a spacecraft designed and built, a mission plan approved and funded. We don't have any of that. So the hitchhiking idea, using lasers to send a message rather than sending a physical spacecraft, might genuinely be our only realistic option for this particular object. It's a desperate attempt, in a way. writing our name on the side of a passing train because we can't afford a ticket, but it's something. And maybe when the next interstellar object comes through, we'll be better prepared. Let me step back for a moment and think about what we're actually facing here. 3i Atlas has passed Earth. It's intact. It's moving fast, faster than any spacecraft we've ever built. It's silent on the radio bands we've been checking, and it's heading for Jupiter, then out of our solar system forever. We will never see this object again. Not us, not our children, not their children. No future generation of humans will get another look at 3i Atlas. This was our one window, our single opportunity to study an object that formed around another star that traveled through interstellar space for millions or billions of years. That just happened to pass through our tiny corner of the galaxy at the exact moment in cosmic history when we had the technology to notice. But Loeb's proposal reframes the entire situation in a way I find genuinely compelling. We've been thinking about interstellar objects as visitors, things that come and go, leaving us with questions and no answers, frustrating us with their brevity and their silence. What if we thought about them as vehicles instead? We're trapped in the solar system, that's just a fact. The distances to even the nearest stars are so vast that with current technology, reaching them would take tens of thousands of years, multiple human lifespans. Entire civilizations rising and falling before the journey is complete. We can't even really imagine timescales like that. They're beyond human comprehension. But if there's a network of objects like 3i Atlas moving between stars, natural objects ejected from other solar systems by gravitational interactions, wandering the galaxy at tremendous speeds, then maybe we don't need to build the entire highway ourselves. Maybe we just need to learn how to catch a ride. The Voyager probes are still out there, still transmitting, still carrying their golden records with messages from Earth. They're our current best ambassadors to the cosmos. But they're so slow. They'll take 30,000 years to reach the distance of Alpha Centauri, and they're not even pointed in that direction. 3i Atlas, or something like it, could potentially carry a human payload to interstellar distances 3 times faster. Still unimaginably long by human standards, but measurably better. A genuine improvement. If we can figure out how to catch these cosmic freight trains, we might have a realistic path to becoming an interstellar species. Not through some breakthrough in physics that may never come, not through warp drives or wormholes that exist only in science fiction, but through patience, cleverness, and the willingness to work on timescales that dwarf individual human lives. Here's how I see the situation right now. Either 3i Atlas is exactly what it appears to be on the surface, a natural interstellar comet formed around another star billions of years ago, ejected from its home system by some gravitational interaction wandering the galaxy ever since, and passing through our solar system entirely by chance, on a trajectory that just happens to take it close to Jupiter and point it toward Epsilon Tauri. If that's the case, if this is just a natural chunk of ice and rock on a random walk through the cosmos, it's still extraordinary. It's still one of the most important objects we've ever observed. It's a visitor from another world, carrying in its composition information about the conditions around a distant star. Every spectrum we take, every measurement we make, tells us something about a place we'll never visit, a solar system we'll never see up close. That knowledge has value beyond measure. Or there's something more going on that we don't yet understand. Maybe the size estimate is wrong and the object is actually much larger than 1 kilometer. Maybe the composition is unusual in ways that explain the anomalous behavior. Maybe there's some physics of interstellar comets we haven't figured out yet. Some mechanism that lets small objects vent aggressively without tearing themselves apart. Maybe, just maybe, there's something about this object that doesn't fit any natural explanation. Something that will only become clear with more data and more analysis. I'm not saying it's artificial. I want to be really clear about that. The evidence doesn't support that conclusion. Not yet, not definitively, and maybe not ever. But I am saying the questions haven't been fully answered. The size paradox remains. The trajectory precision remains. The fragments remain unexplained. And the fact that serious, credentialed scientists like Avi Loeb are now talking openly about using objects like this as transit systems tells you something important. Even in the mainstream scientific community, the thinking is evolving. The possibilities are being taken seriously. March 16th, 2026. That's the next milestone. That's when 3I Atlas makes its closest approach to Jupiter, uses the giant planet's gravity to accelerate even faster, and begins its final journey out of our solar system. Every telescope that can observe it will be watching. Every radio dish that can point in that direction will be listening. And maybe, just maybe, we'll learn something new. Something that changes our understanding of what this object really is. In the meantime, 3I Atlas continues its silent journey through the outer solar system, 60 kilometers per second, faster than anything humanity has ever built, carrying its mysteries with it, revealing nothing, explaining nothing, just moving. And somewhere in the scientific community, in university offices and research labs around the world, there are people sketching designs for interceptor spacecraft. People running calculations on laser systems powerful enough to engrave messages on distant objects. People genuinely, seriously asking the question that Loeb posed: how do we catch the next one? Because there will be a next one. The galaxy is full of these wanderers, these orphan chunks of ice and rock ejected from their home systems and set adrift between the stars. Statistical models suggest there might be trillions of them in the Milky Way alone. And now that we know how to look for them, now that our survey telescopes are specifically searching for objects on hyperbolic trajectories, we'll find more. The question isn't whether another interstellar object will pass through our solar system. The question is whether we'll be ready when it does. Whether we'll have the technology, the funding, the foresight, and the institutional will to do more than just watch it fly by. Avi Loeb wants to send his DNA to the stars. It's a romantic notion, perhaps, a scientist's dream of transcending death by becoming part of the cosmic machinery. But there's something beautiful about it too. The thought that some part of human existence, some message from Earth, could sail between the stars for millions of years, could outlast our civilization, our species, even our planet, could be found someday by something or someone we can't even imagine, and tell them that we were here, that we existed, that we looked up at the stars and wondered. We've spent our entire existence as a species looking up at the night sky, wondering if we're alone, wondering if there's anyone else out there in the vast darkness, wondering if those points of light harbor worlds like ours, beings like us, minds that ask the same questions we ask. And now, an object from out there has passed through our home. It didn't stop to say hello. It didn't answer our radio signals. It didn't leave any obvious message or artifact. It just kept moving, silent and inscrutable, on a journey that began before our species existed and will continue long after we're gone. But maybe that's okay. Maybe the universe doesn't owe us answers. Maybe it doesn't hand us revelations on a silver platter. Maybe we have to chase them, reach for them, work for them across generations and centuries. Maybe the message isn't in what 3I Atlas does, but in what it represents, proof that there's stuff out there, material from other stars, objects from other worlds, and that sometimes if we're lucky and paying attention, they pass close enough for us to see. 3I Atlas is leaving. We can't stop it. We almost certainly can't catch it. That window has closed, if it was ever really open. But the next one, the interstellar object after this one, and the one after that, they're out there somewhere, falling toward our sun from directions we can't predict. And maybe, if we start preparing now, if we start taking these transit opportunities seriously, we'll be ready. Either we figure out how to join the traffic on the cosmic highway, or we stay here on Earth, watching the trucks drive by, forever wondering where they're going and what they're carrying. Either we become an interstellar species, spreading our presence beyond this single fragile world, or we remain what we've always been, prisoners of circumstance, trapped by the vastness of space and the shortness of our lives. Either way, we're not the same species we were before July 2025. We've seen something from another star. We've tracked it through our solar system. We've analyzed its composition, measured its trajectory, and listened for its signals. We've touched, however briefly and indirectly, the larger universe beyond our tiny bubble of warmth and light. And that changes something fundamental about who we are and what we know is possible. The next few months will tell us more. The Jupiter encounter is coming. New observations will be made, new papers will be written. The scientific community will continue to debate what 3I Atlas really is, what it means, and what we should do about objects like it in the future. And we'll be here, covering all of it, trying to understand what's happening and what it means for our place in the cosmos. The universe sent us a visitor. It came from unimaginable distances, passed through our home, and continued on its way. It didn't explain itself. It didn't make things easy for us. It just existed, ancient and strange, a reminder that the cosmos is far larger and far older than we can really comprehend. And now it's leaving, carrying whatever secrets it holds into the interstellar void toward a destination we can only guess at. We watched it come. We're watching it go. And somewhere in between, something changed. Maybe in the object, maybe in us, maybe in what we think is possible.